We are converting the whole chapter pressure into the question answer form. And this is part 4. I am continuously doing this for the convenience of the student who are appearing SEE examination. Okay, let's go to pressure part 4. 31, question number 31. How can we measure upthrust exerted by a liquid on a body? How to measure it? It's very simple. Upthrust exerted by a liquid on a body can be measured easily by weighing the body in air and weighing the same body in liquid with the help of spring balance, because the difference of these two weights is the upthrust. First, we'll weight the body in air and then we'll weight the same body by immersing into water or other liquid. The difference of weight is the upthrust exerted by that liquid on the body. Okay, we can represent it by a formula. Upthrust is equal to weight of the body in air minus weight of the body in liquid. Okay, next question. It is easier to lift a heavy stone inside the water than air. Why? This is because of the upthrust in water is very high, upthrust in air is very less. When a body is immersed in a fluid, then the fluid exerts a vertically upward force on the body called upthrust. Upthrust acts against the weight. Since upthrust of air is very less than the upthrust of water, so weight of the body reduces a lot in water than in air. Therefore, it will be easier to lift a heavy stone underwater than in air. This is the key point. Okay, let's go to another question. Write down Archimedes principle. I am representing this with very big letter. The reason is Archimedes principle is very important, and this is very important for this chapter pressure. According to Archimedes principle, when a body is partially or completely immersed in a liquid, it experiences an upthrust equal to weight of displaced liquid, whether a body is completely immersed in a liquid or sinking, or whether it is floating or it is lying as suspension. In all the cases, the upthrust is equal to weight of displaced liquid, and that can be represented by formula upthrust is equal to weight of displaced liquid. Okay, next question. Verify Archimedes principle experimentally with necessary diagram and method of calculation. First, we have to make diagram like this. In this diagram, what is shown? A body, solid body is weighed in air first, and then the same is weighed in water. And this difference of weight is upthrust, and according to Archimedes principle, this upthrust is equal to weight of displaced liquid. Here empty beaker is weighed W3 and beaker with displaced water is also taken, that is W4. W4 minus W3 gives weight of displaced water, and if this weight of displaced water is equal to W1 minus W2, that means upthrust, then Archimedes principle will be verified. So we can write this way. As shown in the diagram, a body is weighed in air. Let's say it is W1, and then in water, and weight is W2. Weight of empty beaker, let's say W3, and beaker with displaced water W4 is also taken. Now this is the experiment, and these are the observations. Here upthrust is equal to W1 minus W2. We know this, weight in air minus weight in liquid, and weight of the displaced water is W4 minus W3, because W4 is beaker with water and W3 is just the beaker only. And so experimentally W1 minus W2 and W4 minus W3 are found to be equal. It means weight of displaced liquid is found to be equal to the upthrust. Thus Archimedes principle is experimentally verified, which states that upthrust is equal to weight of displaced liquid. This way, with the help of diagram and necessary calculation, we can verify Archimedes principle experimentally. Okay, let's go to next question. Study the given diagram and answer the following question. The diagram is like this. In the diagram, what is shown? A stone is weighed in air and its weight is not given, but the same stone is then weighed in liquid and the weight is given 15 Newton. And how much amount of liquid is displaced is given here, beaker, this is 8 Newton. Now what is the question? Let's say what is the mass and weight of the stone in air? The mass and weight in air is not given, and the question is mass and weight. This is clearly numerical problem. So we have to take the information. Weight in water means W water equal to 15 Newton. It is in the diagram. Weight of displaced water or of thrust. It is also given in the diagram. U equal to 8 Newton. Weight in air, W air equal to question mark. So very easy, we can use this equation. Of thrust is equal to weight in air minus weight in water. And of thrust value is 8 Newton. Weight in air we have to calculate, and weight in water 15 Newton. So weight in air is equal to 8 Newton plus 15 Newton becomes 23 Newton. Okay, one of the part is finished. Now again, what is the question? This is the weight in air, but mass is till now not calculated. With the help of weight in air, we can calculate mass of the body in air. Mass remains same in air and water, but with the help of the weight, we can calculate mass. Weight in air equal to m into g. That means 23 Newton equal to m into 9.8 meter per second square. Now m can be calculated. Dividing 23 Newton by 9.8 meter per second square, we will get 2.35 kilogram mass approximately. The approximately is written because after 2 digit other numbers are ignored, and that's why this is approximately 2.35 kg is the mass of that stone. Okay, therefore we can write one sentence for our answer. Mass of stone is 2.35 kilogram approximately, and weight is 23 Newton. Okay, let's go to another question of the same diagram. How much upthrust is exerted on the stone? This is very simple. The diagram represents the upthrust. It is 8 Newton, isn't it? How much upthrust? It is 8 Newton, because upthrust is equal to weight of displaced liquid. Number 3. In which principle the experiment based on? Write the statement of the principle. This is certainly Archimedes principle, and according to Archimedes principle, when a body is partially or completely immersed in a liquid, it experiences the upthrust equal to weight of displaced liquid. This is Archimedes principle. Okay, let's go to another question. 36. Write down uses of Archimedes principle. Archimedes principle is used in different sectors, but few of them which are very importantly raised, they are what? Archimedes principle is used in different purposes, like number 1, building of hydrometer. Hydrometer is a device which is used to measure density of the liquid. It is based on the principle of what? Archimedes. And number 2, for the movement of submarine in the sea. Sometimes submarine has to immerse more, sometimes it has to immerse less, sometimes it comes on the surface, and it uses Archimedes principle to fly the hot air balloon. Hot air balloon can be flied up to a greater height. Sometimes it has to come down, and it also follows Archimedes principle to move a ship into the water from the land. To move the ship into the water means ship is made outside the water, and it has to be launched to water, and following the Archimedes principle, it is launched into the water. Okay, next. 37. Different weight of a piece of stone on weighing in 3 different media, air, water, and solution of common salt with water are given in the table below. Answer the following question. Medium A, B, C is written, and weight in this medium is given 15 Newton, 20 Newton, and 17 Newton. Let's go the question. Which should be the water, and which one the solution of common salt with water out of 3 media A, B, and C? Be clear about this point. A body weighs very high in air, but it will weigh less in water because water has certain amount of upthrust greater than air, and it weighs very less in saturated solution or solution of salt, because solution of salt exert more upthrust because its density is more. That's why upthrust will be more. So we can answer this way. C is water and A is solution of common salt. C is water and A is solution of common salt. Solution of common salt exert more upthrust. That's why the weight will be decreased to very less value. The weight will be very less in solution of this common salt. So it is 15 Newton. A is common salt, but C is what? Water. Now, if the weight of 1 kg of mass in air is 10 Newton, find out the mass of the piece of stone. Here we have question. In air its weight is 20 Newton. If 10 Newton has got 1 kilogram mass, then 20 Newton weight has how much mass? This is the question. This is a numerical problem. That's why we can say this way. If m equal to 1 kg and w equal to 10 Newton, then we can calculate g, acceleration due to gravity. W equal to mg, w 10 Newton, and mass 1 kg. G can be calculated. It is 10 Newton by 1 kg means 10 meter per second square according to this value. Now we have to calculate the mass of the weight 20 Newton. That's why W equal to 20 Newton. Then W equal to mg, we know 20 Newton is equal to m into 10 meter per second square, and mass of that body will be 20 Newton divided by 10 meter per second square is equal to 2 kg. Directly we can use unitary method also, but it will be better to have this W equal to mg because this is important relation in science. Okay, let's go to another third question. Find out the mass of water displaced by the piece of stone. What is it? Upthrust of water is equal to weight of the body in air minus weight of the body in water. And weight of the body in air is given 20 Newton and weight of the body in water is also given 17 Newton. It means 3 Newton is the upthrust of water. If we have upthrust, that is weight of the displaced water 3 Newton, with the help of this we can calculate mass. Weight of displaced water equal to mg and 3 Newton equal to m into g, and m is equal to 3 divided by 9.8 meter per second square gives 0.306 kilogram. That's why this can be solved. Okay, another question. According to the law of flotation, on which condition does a piece of wood float in water? On which condition? If it is able to displace the liquid equal to its own weight, it can float. It will float on water. According to law of flotation, when a piece of wood displaces the water equal to its own weight, then it floats on water. Now let's go to another question. Why a balloon filled with light gas rises up? Write down according to Archimedes principle. Weight of a balloon filled with light gas is less than the weight of the air which it displaces if we compare. According to Archimedes principle, upthrust is equal to weight of displaced fluid. So upthrust, that means upward force, is more than the weight of the balloon, that is downward force. Hence balloon rises up. Upward force is more, weight of balloon is less along with the gas, and so it rises up. Okay, next. Weight of an object is decreased when immersed in water. Which law does this statement represent? Weight of an object is decreased when immersed in water. Which law does this statement represent? It's very simple. Archimedes principle. Because according to Archimedes principle, every object when placed in liquid, an upward force x on it is equal to weight of displaced liquid. Okay, next 41. Write down the condition of floating and sinking when a body is placed in a liquid. We can answer with the help of density of liquid. If a body has more density, it will sink. If it has less density than liquid, it will float. We can write like this. A body floats on a liquid if its density is less than the liquid. A body sinks in a liquid if its density is greater than the liquid. And a body remains as a suspension in the liquid if its density is equal to the density of liquid. Okay, let's go to another. Write down law of flotation. It's very easy. According to law of flotation, weight of a floating body is equal to weight of displaced liquid. Or we can say this also. According to law of flotation, a body floats when it displaces the liquid equal to its own weight. This is also equally correct. Now we can write formula also. Weight of our floating body is equal to weight of displaced liquid. Next, this diagram is given, and what is shown in the diagram? Overflow can is completely filled with water, And in another one, overflow can completely filled with water, but here is wooden piece also. Question is, with the help of the information given in the diagram, answer the following question. What fact is shown to be verified by the given diagram stated? This is actually law of flotation is experimentally verified. Given diagram shows the experimental verification of law of flotation. According to this law, a floating body displaces the liquid equal to its own weight. Look at this. Here, the combined weight of this overflow can and water is shown here. And here, combined weight of not only overflow can and water along with wooden piece is shown here. And value of weight is shown to be equal. What it mean? The extra weight of wooden piece is gone somewhere. How it is possible? Where it gone? Because when a wooden piece is taken in this water, then it displaces the water equal to its own weight. That's why combined weight is again the same. So this can verify that a floating body displaces the liquid equal to its own weight. What will be the difference of weight in two different cases shown in the diagram? They are equal. In both the diagram, A and B, weight shown by the top and balance will be equal. Okay, let's go to another question. Why a ship loaded with cargo immerses more in water? A ship loaded with cargo is heavier than empty ship. According to the law of flotation, weight of floating body is equal to weight of displaced liquids. Since ship is heavier when loaded with cargo, so it displaces more water equal to its own weight. Hence, a ship loaded with cargo immerses more in water. Okay, next question. What is the difference between an empty ship and loaded ship moving on the sea water? The same question is asked in different way. According to the principle of flotation, the weight of a floating body is equal to weight of displaced liquid. Weight of empty ship is less than the loaded ship. So, an empty ship immerses less than loaded ship to displace less amount of water equal to its own weight. Therefore, an empty ship immerses less, but the loaded ship immerses more in seawater. Now let's go to another question. Why an iron nail sink in water but a ship made up of same iron floats on water? Very interesting. Why nail sink in water but a ship is also made up of iron? It won't sink in water. What is the reason behind this? There is hollow space in the ship. This is the major point. Now, how can we write clearly? According to Archimedes' principle, upthrust is equal to weight of displaced liquid. Weight of iron nail is greater than the weight of water displaced by it. So, weight of nail is greater than the upthrust. Hence, it sinks in water. But a ship is made in such a way that it has a lot of hollow space inside it. So, it can displace enough water equal to its own weight. And according to law of flotation, upthrust is equal to the weight of displaced liquid. So, upthrust becomes equal to the weight of the ship. Hence, the ship floats on water. This is the reason. Okay, next. Only the objects having density less than water floats. Is the statement true? Why or why not? Give reason. It was discussed just before this. This statement is not true. A body having lesser density than water floats on water, but a body having density more than water can also be made to float on water. If it is made hollow inside, then it becomes able to displace the water equal to its own weight. According to the law of flotation, when a body displaces the liquid equal to its own weight, then it floats on liquid. So, a body having density more than water can also be made to float on water. Let's go to another question. What differences will you get from the flying of air-filled balloon and hydrogen-filled balloon? Certainly, air-filled balloon goes down and hydrogen-filled balloon goes up. The reason is weight of air-filled balloon will be more than the air displaced by it, but the weight of the hydrogen-filled balloon will be less than the air displaced by the balloon. According to the Archimedes principle, upthrust is equal to the weight of displaced fluid. So, the upthrust on the air-filled balloon is less than its weight, so it falls down. But upthrust on hydrogen filled balloon is more than the weight of the balloon, so hydrogen filled balloon rises up. Okay, next go to another question 49. One feels difficult to breathe in the deep well while cleaning it. Why? This is carbon dioxide. Carbon dioxide gas may be collected in the deep well by the upward displacement of air because its density is greater than air. CO2 gas does not support respiration, so it will be difficult to breathe in deep well while cleaning it. Now, next question. It is easier to swim on the sea than that of a pond. Why? We can swim easily in sea water than in pond water. The reason is very simple, the density. Because salt is dissolved in sea water but not in the pond water, so the density of sea water is greater than that of the pond water. A dense liquid exerts more upthrust than a less dense liquid, therefore it is easier to swim in sea than that of the pond. Okay, we have done up to 50. Now in next class I'll continue this much for today.